This particular problem asks us to do error analysis, and error analysis is particularly tricky because we have to try to figure out how the other person was thinking. So if we look at our problem, my classmate simplified the square root of 5x cubed times the cube root of 5xy squared to be 5x squared y. What mistake did she make, and what is the correct answer? Okay, so I need to think, how would I get to 5 if I had the square root of 5 and the cube root of 5? Well, what I'm thinking is perhaps my classmate didn't see that cubed root and just treated it like a square root. Because if that's the case, that means that this would become the square root of 25, because that's what 5 times 5 is. And if I multiply x cubed times x, I get x to the 4th. And then I just have the y squared. So if I take the square root of 25, I get 5. If I take the square root of x to the 4th, I get x squared. And if I take the square root of y, I get y. So the mistake was, this here was the mistake. Did not use cube root. Okay? So now we're given the task of trying to do it correctly. So let's try that. So this is a square root and this is a cube root. Because they're different roots, I cannot combine what's underneath the radical. So to help me do this, I'm going to do rational notation. Okay? So instead of writing this with a radical, I'm going to write 5x cubed to the 1/2 power. And I'm going to write 5xy squared to the 1/3 power. So now I have a power to a power. So when I have a power to a power, I multiply my exponents. I have to remember my 5 has an exponent of 1, and my x also has an exponent of 1. So that gives me 5 to the 1/2 power times x to the 3/2 power times 5 to the 1/3 power times x to the 1/3 power times y to the 2/3 power. I just multiplied my exponents by 1/3. So now I'm going to use the commutative property of multiplication, which means I can rearrange the order in which I determined to multiply. So I'm going to put my similar bases together. So this is 5 to the 1/2 times 5 to the 1/3 times x to the 3/2 times x to the 1/3 times y to the 2/3. So when I'm multiplying same base, I add exponents. So this is 5 to the 1/2 plus 1/3. This is x to the 3/2 plus 1/3. And this is y to the 2/3. So when I add my fractions together, just do a little bit of work over here, I have 1/2 plus 1/3. I need to get common denominators. My common denominator is 6. So this is going to be multiplied by 3 over 3, and this is going to be multiplied by 2 over 2. So I get 3, 6 plus 2, 6, which gives me 5, 6. So that means this is going to be 5 to the 5/6 power. I'm going to do the same thing with my 3/2 and my 1/3. Common denominator again is 6, so that's 3 over 3, and this is 2 over 2. So this gives me 9 plus 2 over 6, which is 11/6. So that means this is x to the 11/6, and then I have y to the 2/3. Okay. Now, upon close examination, 5/6 is less than 1. 2/3 is less than 1. But 11/6 is not less than 1. It's greater than 1. So I can make this into a mixed number. So 11/6 is the same as, well, 6 goes into 11 one time, and then 11 minus 6 gives me 5, so that gives me with 5/6. So my mixed number is 1 and 5/6, so I'm intentionally going to put that plus in the center. That makes this 5 to the 5/6 power, x to the 1 and 5/6 power, and y to the 2/3 power. So I'm doing my multiply, same base, add exponents backwards in reverse. So that means this becomes 5 to the 5/6 power, x times x to the 5/6 power, times y to the 2/3 power. Okay, so there's a curious thing happening here with my exponents. I notice that this has a denominator of 6, and 6 is my root. This has a denominator of 6, and 6 is my root. But this one has a denominator of 3. So I don't want to have two separate roots. I want to have the same root. So I can take this exponent, 2/3, and I can multiply it by my magic number 1 to get the same denominator. So if I multiply 2/3 by 2 over 2, that makes my y have an exponent of 4/6. I'm going to bring this here, which is 5x to the 5/6. I'm going to slip this one over here, because remember I can switch order. 5 to the 5/6, and then x. So all I did was rearrange my order. The reason I did that is because all these roots are the same. X only has an exponent of 1, so it's no longer under the radical. I now have the 6th root, because these are all coming out, of 5 to the 5, x to the 5, and y to the 4th. So if I want to expand my 5 to the 5, I simply can put that in my calculator, which gives me x times the 6th root of 3,125, x to the 5, y to the 4th. And that's my final answer.